That's the equations you never have to use. I had to use it to build the damn thing. I put it there, so when I was setting my spreadsheet up, I got the formula right. Because I don't memorize these things, you shouldn't either. What do you notice about the shape of that bad boy compared to the bell curve, compared to the T curve and the Z curve?
Skewed.
Highly skewed. Highly skewed, yes. It's definitely a skewed distribution. It will start to bell out over time with more and more categories of observations, but in small numbers like we'll be testing in this class, like the AHA test on your last exam, like the M&Ms we'll test next class, it's definitely a highly skewed distribution. Look at the horizontal axis. Notice the smallest value is 0. Just like you said over there. It can't be below 0, it can't be negative. It's got to be 0 or positive. As it stretches away, it's pretty clear that these numbers over here are getting far and far and far away from 0. By far, I mean look at the height of the curve. The height of the curve tells you how likely certain things are. The height of the curve tells you how likely certain things are. So Mel, back to your question from 25, 30 minutes ago. You said, isn't it kind of unlikely that everything will go up exactly at 10%? Yes. Look at where that curve is right there at 0. It's at a probability of 0 as well. So when there's perfect agreement between the O and the E columns, there's almost no chance of that agreement. The height of the curve talks about the likeliness, which means the function itself knows that here's where the lion's share of what would happen if the randomizer was working will happen. You would expect the test statistics somewhere between 0 and 15, more likely in this chunk of region right here. Yes, exactly. Where did we land? What was our test statistic? I'm going to risk of putting this up and not reaching it again. Our test statistic, can I erase this? Is that okay? Because you have the hypotheses, right? Our test statistic landed at 6.8. So here's 5, here's 7.5. It's about here, yes? Is that a pretty tall probability on that curve? Hell yeah, it is. And the way you get the p-value, just like all other p-values, and you have a whole exam question devoted to this, is you shade to the right on this one. You always shade into a tail. And this is, again, you have an exam question about this. I want you to leave this class, if nothing else, you've got a working knowledge back and front what a p-value is. That's what, and then all the way, this thing goes on forever. This thing goes on forever in the tail. So, forever that way. What do we just shade, friends? What do we just shade? If you had to give that a percentage, what would you call it? If you had to estimate what percentage of the curve I just shaded. Give it a ballpark.
Less than half.
Less than half? But more than 5%, I think, yes? So if I vote for less than half, I agree with you, Danielle. I think I'm going to guess around a third. I'm going to call that 0.3333. Now here's the deal. I will never ask you to calculate this without using technology. This is ridiculous. You have to evaluate that without using technology. It's stupid. So what I did for this and only this example is, I set up Excel to do it. If you put in the 6.8 test statistic, hot damn, look at that. It's actually 24%. We were damn close to a third. I accept that. The p-value for this bad boy is 24%. Big, small? Big or small?
Big.
Big, bigger than 5%. So we have a p-value, we got a test statistic. Chi-squared is 6.8. That's our test statistic. Big p-value, 24%. What does that mean?
Means that we support the null hypothesis.
We do, which means, now there's a couple ways you can write this. What are you going to circle? If you go with our normal circling, wouldn't we circle it does not appear?
Yeah.
We would do that, right? Now this is going to sound a little convoluted, but what does it not appear?
Well, it's working, so you can't say it doesn't appear.
It doesn't appear that it's not working. This is where it's going to sound weird if you stick with tradition. It doesn't appear that it's not random. Does that make sense? Because what you're doing is, that appears and does not appear, that appear and does not appear bit, is referring, which I've now erased it, is referring to the research hypothesis. So in other words, it doesn't appear the research hypothesis is true. The research hypothesis says that it's not random. So it doesn't appear that it's not random. But that's like double negatives. So you can, of course, if you want to, just put it appears it's random enough. That's okay too. But if you want to keep with the tradition of when the p-values are big, it says does not, just make sure you phrase it correctly. It doesn't appear, it's not random. Does that make, you guys, I apologize for the English language getting in the way here. It doesn't appear that it's not random. In other words, it appears that it's random. So you say that they mean they're equivalent meanings. But if you want to keep the pattern we've created in this class, big p-values mean your circle does not appear. Just make sure you phrase the research hypothesis after that. Could we be wrong?
Yeah.
Of course. With a still type 2, false negative. Saying that it appears to be random enough when it actually isn't. But we agreed that we didn't care too much about type 2. We cared more about type 1. That's a lot of math. I apologize. That's a lot of friggin' math. And a lot of this gamma function, degrees of freedom stuff. So let's figure out how to use technology to get all the stuff that we need. Because that honestly, this is tedious, extraordinarily tedious. You guys have any questions before we move on? Fair enough? We have to. I mean, this is great. I wish we could use this together every time, but we can't, unfortunately. You may have noticed there was a thing down here for degrees of freedom. The curve changes. I'm going to erase this real quick and show you before I get you into the calculator. If you have different numbers of categories, for example, if you have, say, 12 categories, 12 categories, the curve actually does change quite a bit. Crap, I just realized something. We have 10 categories, not 6. So your p-value is actually, sorry, change this, friends, because you'll get pissed off in a second when we use the TI and it doesn't agree. Your p-value is actually 66%. I forgot to change Excel up top to 10 and not 6. You have 10 songs, not 6 songs. Apologies. Your test statistic's still 6.8. We calculated it up here. The p-value should have been 66%. Danielle, you were correct in your analysis. It would have been this then. See how the curve changed when we had more category? When I asked you how big it was, you said it's less than a half. Now it's clearly more than a half because the curve shifted. And I apologize, friends. I should have caught that. I should have looked up there carefully. This is one of the annoyances of this curve. This curve, all these K's that are up there, that's a function of the number of categories. So, as that K changes, the curve itself changes. So when you have, say, 15 categories or 20 categories, notice it's becoming less skewed, but it's still skewed. Technology takes care of all that for you as long as you know what to do. Now, I wrote the program for you. Grab your TIs. I wrote the program for you so you wouldn't have to remember to do that. It does it for you. You're welcome. And the reason I did that was that some of your TIs actually have a built-in called goodness of fit. We'll take a look at it here in a second. But mine works a little bit more automatedly than theirs does. So, first, run around this way. Let's go to the TIs. The first thing you have to do, all you've got to do is put L1 and L2 into L1 and L2. You have to start with that.